Hey everybody, welcome back. Today we're going to talk about samples and populations and why that's important for researchers and specifically in statistics. Okay, so researchers need to be very cautious about where they're getting their information from, because if they're getting their information from a source and then attributing it to another source, for example, that's going to cause a lot of problems. And hopefully that'll make a little bit more sense as we talk about what we're going to talk about today. Okay, but it's very important that we're assessing for patterns and we attribute those patterns to the correct places. Okay, so that's what we're going to talk about today. We're going to get some new terms here and some definitions, and specifically related to data sources. So specifically, two terms we'll be talking about are samples and populations. Now, I think it makes the most sense to start off talking about what a population is, and then we can make more sense of what a sample is. So a population in very simple terms is everybody who fits a specific kind of description or definition. Every single person is often what we're talking about in psychology, but it could be other units as well, just any kind of unit that you're gathering data from. Okay, for example, it could be a day, it could be, I don't know, a tree species or something like that. That's fine. So for example, the one population is called Generation Z. Okay, so when somebody says Generation Z is blah, 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 what they're referring to is everybody who is born between certain years. And they're referring to absolutely everybody who fits that description, right? So that would be a population. Everybody who is born within these 2 years, or in these years of a certain time frame. And I don't know what the definition is, but everybody who fits those is called Generation Z. Okay. There's also a population called conservatives, right? When people say that word, they mean a group of people. They're talking about a group of people, and you know if you fit into that group or not, probably, or at least you have a good guess. You may be, curious about the actual definition, and that's something we'll talk about in just a moment. But that's important, right? So they're referring to a very large group with this term of population. Okay. There's also palm trees, right? If I say, palm trees are blah, 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 I'm referring to lots and lots, thousands and thousands, maybe even more than that, of a particular kind of tree. And I'm also suggesting that those trees share a characteristic or several characteristics. For example, they're the same species and things like that. And what I mean by that is they share the same genetic makeup, essentially, at some base level. Okay, so there are lots of populations that we could refer to, and there are lots of populations that would interest researchers for lots of different reasons. For example, they might be interested in Americans. They might be interested in juvenile delinquent Americans, right? And so they're trying to understand patterns about that population so that they can now make sense of the population, and then hopefully find patterns that they can help the population, help everybody to know things about that population, for example. Okay, so once again, the population includes every single unit that would fit a specific definition. So let's now get into the definitions a little bit and why that's important. Okay, it's very important for a researcher to understand and to carefully define the population that they're interested in. Not only the population, but also sort of the measures they're using and things like that. But we're just going to focus on the population they're interested in. So for example, if somebody is looking at their study and saying, "Oh, that's an interesting study. Would I fit their population of interest? Are they interested in my information? Do I fit that population?" It should be very clear whether I fit that population or not. Okay, so let me give you a few examples. A very vague description might be a researcher says, "I'm interested in people who have broken the law." Okay, so if you read that, do you belong in that study or should you not bother taking that study? And you could pause the video and think about that for a minute. Um, Essentially what's going on here is you're going, well, what do they mean broken the law? Because I mean, I've sped a couple of times. I jaywalk occasionally. I've sometimes I've been late paying my taxes or something like that, right? So have you broken the law, or did they mean something more serious? Now, if it's vague like that, if you can't tell, do they want me in this study or not? That's a problem. That's a problem with their operational definition. When you can't tell if you're part of the population that they want in their study or not, That's a very vague and terrible description. So let's see if we can make it clearer. If I said something like, I'm interested in my study in adults who have been convicted of a felony at the state or federal level in the last 5 years. Now that should be very clear whether you fit into that population or not. Okay. And you could say, oh, okay, well, I mean, I've broken all sorts of traffic laws, but I've never been convicted of a felony. Or you say, well, I was on trial for murder, but I was actually acquitted. So now I can see right here, they only want people who are convicted, right? I'm making that up, by the way. I've never been on trial for anything like that. Another vague definition might be something like Christians, right? Now, you might know whether you say that definition seems to fit me or not, but if it may not be clear for what they're looking for in the actual study. For example, Christians can differ in a lot of ways, even a lot of belief systems, and certainly in practices. So if you're a researcher, you might be specifically interested in Christians who have attended church at least once per month, and they've done that for the last year, right? So think about this. There are lots of very important definitions to think about. Like, for example, are you a smoker or not? Might be interesting. Well, for example, I have a neighbor who doesn't smoke cigarettes ever, but every time he mows his lawn, he lights up a cigar and he smokes the cigar while he's mowing the lawn. So is he a smoker or not? That's a very important thing that a researcher needs to decide. So would he fit my definition or would he not fit my definition? Are we talking about smoking cigarettes? Are we talking about vaping? Is that included? Are we talking about cigars? How frequently do you have to smoke? What if somebody is quitting cigarettes? Are they still considered a smoker? What if somebody just started smoking 3 days ago? Should they be included in my study? So you have to set up all of these criteria to decide what is my population. That's very important because, well, for lots of reasons, but because if you're starting to get people who, let's say it is smokers, for example, if I'm interested in smoking behavior and I have a lot of people in my sample, I haven't described that yet, but I have a lot of people in my study, we'll say, who just started smoking, they're not going to fit, they're not giving me accurate data necessarily that I should then publish and say, look at all smokers. Smokers have this pattern because I'm actually just talking about new smokers or mostly talking about new smokers. And so they've skewed my data in a way, right? All right. So let's talk more about this now. It's very difficult to get research to get research involving populations. In other words, to get data from the entire population is very difficult because they tend to be very large. Imagine that. Imagine I wanted to do a study on Christians in the United States. That's millions of people, and I'm very unlikely to be able to get every one of them to agree to take a survey, right? I don't have the money for that. I don't have the advertising power to start getting people to do that. So that's very difficult. But if my study is about Christians, I want to be able to have information about as many Christians as I possibly can. Otherwise, why do the study? I'm kind of wasting my time, aren't I? Because I'm not actually providing information. So because they're so difficult to study, we're generally stuck with getting samples of our populations. Now, a sample is a smaller section of the population. It's more realistic to get a sample because it's not everybody in the population, it's just some of the people in that population. For example, I might be, if I'm interested in Christians, maybe I just say, well, I'll just study Christians in my area and hope that that kind of represents all Christians in the United States. That's probably not a great idea, but maybe I could get just a few people in every congregation in the surrounding tri-state area, for example. I'm not getting everybody, but I'm getting some people, and it's expanding my knowledge. It's getting me some data that hopefully will apply to the population. Okay, so generally it's difficult for researchers to get populations, and we rely on smaller samples of the population. So this Venn diagram is one way to look at that. In other words, the population would be everybody I'm interested in, like smokers. This is every smoker I'm interested in, everybody who would fit my definition of smoking. And you as the researcher decide what is your definition. Then I probably can't get everybody who is a regular smoker for they've regularly smoked for 2 years or whatever, at least. And so I have to get just some of the people who fit those criteria. Now, this can be a big problem if I'm oversampling people who are just a subsection of my population as well. I don't want to go super into that just for time's sake, but imagine, for example, I'm interested in smokers and I get a sample, but the sample is just people who regularly smoke cigars. And they're sort of cigar connoisseurs, you might say. They're not really matching. They're not really representative of the people who are smoking, 60 cigarettes a day. And I've known people like that, right? And so what I want to do is have my sample be relatively representative of the entire population. Okay. Yeah. So the sample is hopefully going to represent the entire population as well as possible given the limitations of the sample size. Okay. The best way that we can do that is something called random selection. Random selection by definition is when everyone in the population has an equal chance of being in the sample. That's all that is, but it's so powerful. And it took centuries for human beings to realize the power of random sampling. So don't take it for granted. It sounds very simple, I think, but it's very important and complicated. So I'll say it one more time. Random selection is when everybody in the population has an equal chance of being in my sample. It's very difficult to do in reality, depending on the circumstances, for lots of reasons. For example, you just have to hope that the population's subgroups are also relatively equally represented in your sample. That can be very difficult. There's some other methods that you can do to try to make that make it occur to have your sample generally represent the population. Something called stratified sampling and things like that. A little beyond what we're doing here, so I won't go more into that. And it's important here that statistics, the entire thing that we're talking about in these little micro lessons, statistics are characteristics of samples, and they are intended to represent the population, at least, I should say estimate the population's characteristics. But the population's characteristics are called parameters. Okay, so I may be using those words throughout. So if I say a parameter, that means I'm talking about the entire population, and this is an actual characteristic of the population. If I mention a statistic, that is a characteristic of a sample, and I also hope that it is representative of my population. Okay, so quick recap of what we covered today. Researchers are very interested in large groups usually, and they want to know a lot of people about a lot of things about those large groups. Okay, but because it's very difficult to study everybody in those large groups, we usually are reliant upon only samples of populations, and statistics are characteristics of just samples and not populations. Let me give you one quick last tip here as well. If you've got, like you may say, is this a sample or a population? I'm not really clear on that. One way to sort of think about this is, number one, do you have everybody you will ever be interested in applying the information you have to? Like, let's say, for example, I'm teaching a class. I'm teaching a statistics class, we'll say. And I have a grade, an average grade for my statistics class. And I say, oh, on average, people got a B- in this class, for example. Now, is that a statistic or is that a parameter? Well, it really depends. Do I want to use that grade, that average grade that they had, for just that semester, and I'm not going to use it for anything else? I'm not using it to predict or estimate what the grade is going to be next semester. If I'm never going to use it for anything else, then that applies just fine to a population of just that course that semester, as long as I have every single grade from every single student who is enrolled. However, if I want to say B-, oh, now I'm going to tell my future students, hey, your best guess for your grade in this course is a B-. Now I'm using it to predict the future, and I'm including the future course in my population, and I don't have data on them yet. Therefore, that would certainly be a sample or a statistic. The grade itself would be a statistic. Anyway, these kinds of things take some practice to get working on, but there was a quick introduction. Went a little longer than I thought, but thank you very much. We'll talk about more things later. Thank you very much.